This video is going to look at a little bit more in depth into each of the 18 groups of elements on the periodic table. So elements have this, in the same column, have the same number of valence electrons. It gives them many similar properties. So let's start in with them. All right, so starting with group 1. Group 1 has 1 valence electron. This makes them highly reactive. The very first element in that group is hydrogen, and it is a gas. It is a nonmetal, and it's the most common element in the universe. And so it is the only nonmetal in that group, and we call this group the alkali metal groups. This is the metals in group 1 of the periodic table that has only 1 valence electrons, and they're highly reactive. In nature, they have to be combined with another element or 2 atoms of itself. They're very, very soft in that they can be cut with a butter knife. They're low in density. And they're solid at room temperature. Here's your example of group 1. It shows you all the elements here in group 1. And it pulls out sodium to show you that it is a soft metal and it's very reactive. But when it's combined with chlorine, it makes our table salt. Group 2 elements are called alkaline earth metals. They're located in group 2, and they also have 2 valence electrons. This is another very reactive group. However, it's slightly less reactive than the alkali metals. Again, these guys are always found combined with other elements. Otherwise, they would react. And they are usually silvery gray in color. They're a little bit harder and denser than the alkali metals, but they're still solids at room temperature. Group 13 through 12 is what we call the transition metals, and they are hard, again, and shiny, but they're less reactive than either the metals in group 1 or 2. This is because they have more valence electrons, and many of these are also silver in color. Like I said, they're very hard. They have high melting and boiling points. All of them are solids, except I believe in the last video we talked about how mercury is not. Remember, mercury is a liquid. These also include the elements listed below the periodic table. Remember, those get pulled out. The lanthanides and the actinides get pulled out and put below the periodic table so that it can fit onto one page. Those lanthanides are shiny and they're relatively reactive. And the actinides, they're actually radioactive. And many of them do not occur in nature, meaning that they were man-made. And so here's your transition metals. They're the lower ones in the periodic table, and here's that series of lanthanides and actinides that get pulled out. So group 13 through 16 are groups that contain metalloids. They contain at least 1 or more metalloid. Group 13 is known as the boron group because the boron is the top element in that group. And the only metalloid is actually boron in this group. The 4 other elements are metals. They have 3 valence electrons, and they're fairly reactive. And again, they're solids at room temperature. So what you'll notice here is that we still have a pattern with these valence electrons, that this is the 13th group, and it has 3 valence electrons. The next group here is carbon. Again, it's the carbon group because carbon is the element listed at the top of that column. It is a nonmetal. Directly below carbon, the next two elements are metalloids, and then the last two elements in that column are metals. In this column, since it's group 14, there's going to be 4 valence electrons. This group is not very reactive because of its 4 valence electrons, but all of them are also solids. Group 15 is called the nitrogen group. And here the first two elements are nonmetals. And then we have 2 metalloids, and then the last one is a metal. Here, group 15, the 5 indicating 5 valence electrons, and their reactivity varies, meaning some of the elements in this group are very reactive while others are not. Nitrogen would be one of those that is not reactive at all, and it's a gas at room temperature. However, phosphorus is very reactive, and again, since it's so reactive, it has to be combined with other substances in nature. All of these elements are solid. Group 16, this is our oxygen group. The first 3 elements are nonmetals. Then we have 1 metalloid followed by 1 metal. Group 16 indicating 6 valence electrons. All of these are fairly reactive. Oxygen will often react with metals to form rust, and rust is a form of compound called an oxide. It is a gas at room temperature. And then the other 4 elements are solids. So here's the start of groups 13 through 16, showing you the various compounds. Notice the top element is the name that each of those columns receives. And then the color coding tells you what class of elements, whether it's metals in blue, metalloids in that orange, or nonmetals in green. Group 17 is called the halogen group. All of these are nonmetals. They're located in group 17. The 17 indicating 7 valence electrons, and these are very reactive. And they like to react with the alkali metals because the alkali metals have 1 valence electron, and that 1 valence electron plus the 7 valence electrons of halogens, 1 plus the 7, gives us 8 valence electrons very easily, and that's what the compounds are trying to achieve. So when they combine, they will form a salt, and we can see that with sodium and chlorine. When they combine, they make table salt, the salt we can eat. The gases, this group has gases, liquids, and solids. Chlorine is an example of the gas, bromine is a liquid, and iodine is a solid. So again, we have your halogen group, starting off with fluorine. Bromine's in there as the liquid. Iodine is a solid. And then fluorine is a gas. The last group, group 18, are called the noble gases, and they have 8 valence electrons. Group 18, 8 valence electrons. And the only exception here is in the case of helium, they only have 2 valence electrons. And these are unreactive because they have a complete outer energy level. So helium has 2 valence electrons, which fills, so if this is our nucleus and we have our first energy level, 2 valence electrons fills that first energy level, so that's why it gets grouped with the noble gases. These are generally colorless, odorless, and they're gases. So like I said, their outer energy level is full. They're not reactive, and they will seldom combine with other substances. However, some of them do have the ability to bond to themselves. So here's your examples. We have helium to start off the family, and it works its way down to argon and krypton and xenon and radon.